That's quite a difference there, as you can see. So what I've done so far is I've recapped the entire radio, replaced all the caps that needed replacing, and those are obviously the yellow ones, and there were quite a few. There were a lot of capacitors, a lot of the tonal capacitors, because this has got this is a stereo output, so everything from preamp onwards is in duplicate. Those two little boards there were quite a challenge to remove, but they came out quite well. They actually ended up being the easiest ones to replace, because some of these guys are really, really tough. You have to get right in there with a soldering iron, make sure you don't damage anything else, and to get them properly soldered in. All the capacitors removed from here were a complete waste of time. They were definitely gone. So there was no point in actually testing them. I know they're dead, or at least they're beyond their spec. So they were all replaced, and the result is actually quite amazing. There is something else that I want to draw your attention to. You see that resistor over there, and that one over there, and that one over there. These resistors are sneaky. They're actually pretty good in terms of value, but they have another problem, which I'll show you in a second. So I had to be very, very careful with the resistors. I had to check some of them, and I came up with, I actually discovered 3 that were open. Now, all these were actually in the tone control circuits, so they didn't actually stop the overall working of the radio. It just meant that they didn't, the result wasn't as good as it could be. So they would have gone quite happily, undetected. You just wouldn't know that there was something wrong with them, unless you did some pretty in-depth research, which is what I did on these schematics and measuring the circuit out. Right, so those were done, and also I have restuffed the Selenium rectifier with 4 silicon diodes, 1 N4007 ultrafasts. I stuffed them into the case, and I'll show you in a minute how that was done, so that visually it doesn't create an eyesore. This thing looks more original this way. Everything else is done, and the result is quite impressive. But more about that later. So here are 2 of those resistors I've replaced, and I want to show you something. This is the first time I've seen this. It seems that there's nothing wrong with them until you do this. See that? That end comes off completely. It's completely detached. So is that one. Now, obviously, continuity is broken when these split up. And the problem is that when it's in circuit, you don't really see that. And finding them was one hell of a problem. Especially, as I said, they were in the tone circuits. So I only found the first one by chance, because I touched it and it broke apart. And that made me go and test all the others. And I found 2 more. So rather sneaky, but those were done. As you can see now, we have quite a bit more painted up. In fact, a lot of this was not painted. I didn't follow my usual scheme of painting in or coloring in every single component. I just went and checked it along the way, and the ones I've replaced have been marked in green. So we have 1 preamp tube over here. This is actually half of a tube. The other part is on the other side. This is the triode section, and we have a single triode here as well, which acts as a second channel. So we actually have 2 different tubes acting as the two preamp tubes for left and right channel. I wondered about that because to get the characteristics or to get the response exact on those two triodes would be quite a challenge. I presume that the ABC80 has a triode very similar to the EBC91, which is why they used two different tubes to create this the preamp. We've basically got one preamp stage, one triode stage acting as a preamp for, say, the left channel, and another preamp stage for the right channel. These are all, this is the volume pot over here and here. It's a single pot, dual ganged. As usual, it has all the tone correction circuitry that comes off one of the tappings on the pot, so you get a loudness effect at low volumes. It then also has a feedback network from the output transformer. Okay, there you have negative feedback. So this whole thing here has to do with tone. There's this button here, C, which is for extra bass. If you follow the logic of this, this one's actually quite understandable compared to some of the ones I've seen. But this is one section, and this is one of those little boards that I showed you, and this is the other section. This is the other board that I showed you. The phono input is over here. That's now all working. These switches allow you to select between, this first one here will select the tape input. There's a tape input and a tape output, so you can actually feed in a tape signal and record from it as well. You're actually recording from this point here, which is the input to this audio preamp. So effectively you would be able to record left and right channel of whatever is going through the radio. If you choose tape, then the signal stops there. It comes on from that point there, so that point there is selected up, nothing else comes in. Assuming you don't choose tape, it's down, and it then gives you an option of selecting your phono input or something else. So if you choose phono, it stops there, that signal stops there, you get the signal coming in through here. If you don't choose phono, then you're choosing radio. If you're choosing radio, you're either going to go for AM or FM, which is that switch over there. One of them is FM and the other one is AM. So if you choose FM, the AM is deactivated, and so on and so forth. And further back, you've got another switch, which if on AM, you can choose long wave or medium wave. So this whole thing works in almost like a set of sluice gates that you open and close depending on what signal you want to get through. But all that is working, and it's working pretty well. The other thing that was still needing some attention was the power supply. If you recall, we were getting about 200 volts on here as opposed to 278, and 153 or so as opposed to 215. Now I decided to go ahead and do all the repair and all the correction with those voltages in place, because it would mean that the radio is under less stress, lower voltage, less stress, and provided things worked anyway, it's safer to do it that way than to do it the other way around. Safer for the hobbyist as well, believe me. But once that was completed and everything was working, I decided to do what I had intended to do originally, which is to replace the Selenium rectifier with 4 silicon diodes. I used 1N4007s, and I will show you next how that was done. And the result, which I expected, was a much higher voltage over there, because the loss through the silicon diodes is much lower than it is through a Selenium rectifier. What we're getting there at the moment, we'll check in a minute, but it's certainly back up to more or less what we want. And the one possibility that I'd looked at was that we need to put a resistor in series with this line here to drop any excess voltage. As it happens, that was not necessary, and I'll show you in a minute. The other alternative would have been to drop this AC voltage coming in, so that overall the voltage output would be lowered, but it has not been necessary. And I'm glad it hasn't been necessary, because usually this thing is drawing 112 milliamps. 112 milliamps, let's say you wanted to drop 20 volts, I squared or VI, so you've got quite a lot of power in those resistors. And they do tend to heat up quite a bit. So you have to choose a good power resistor. You have to put it in a position in the radio that won't create havoc by excessive heat. They do get very hot. So they're always a little bit messy, and if you can get away with not putting it in, great. And because I've chosen the 240 volt input here, which this particular radio does have for the primary of the transformer, it worked out that my result here was close enough to that without needing any resistor, which is brilliant. Okay, so let's go and look at what voltages we've got here. Okay, so I've switched it on. I've connected the negative of the meter to ground on the chassis, and let's measure the voltage right there on that first cap, which should be 278. 271.5, 272. That is near as damn it what I want, and I'm happy as a pig in mud. 272. That's pretty close, very close. And that is using the 240 volt input here, and just with diodes, no resistor. The second voltage, call that 212. That there is 212, which is this one here, 212. It's supposed to be 215. I'm happy. That is perfect. And so what I've done here is I've not increased the voltage here. Therefore, I should have a fairly good heater voltage. Let's see what the heater voltage is. .6 volts AC. So 6.6 volts AC. It should be 6.3, as for most of these heaters. All these heaters, in fact, work on a 6.3 volt heater voltage. So I have a little bit over, but not much. That's good enough. The other voltage I'd like to measure is the AC ripple on that first filter cap. So let's see what we've got. 6.26 volts AC ripple. Now that means here 6.26 volts AC ripple. That is, it looks high, but actually it's not, because if you look at it percentage wise, it's 6.6 over 272. It's, what is it, 2-3%? And more importantly, you don't hear it. This ripple is obviously going to the transformers. It's 100 hertz ripple because it's going through the Selenium rectifier, which is a full bridge rectifier. So you could hear 100 hertz hum if it was loud enough. And what I found when testing the amp is I don't measure that hum. I don't hear the hum at all, which means that for all intents and purposes it's fine. You can get away with actually quite a bit more. Ideally, with this type of amp with single-ended stages, you want the ripple to be as low as possible. People quote up to 5% as being fine. I prefer to get it down lower, but what you got to do is use your ears. I don't hear any hum, so there is no hum. Okay, it is an audible thing. If this was a push-pull amplifier, you could get away with a lot more ripple, because the one when you got one stage with two tubes acting in push-pull, they tend to cancel each other out. So that's basically a common mode noise, and that noise gets cancelled out by the opposing forces of the push-pull stage. But in this case, it's low enough that it's not affecting us, so we don't mess with that. Okay. The other voltage that I wanted to check is on the output stage, and it is the, where is it, anode voltage, 6 volts, and whoops, 5.96. Those there are over here, 6.0. Those two are on the, that's over here, 6 volts, and on the opposite one, 5.96. It is slightly low. but that's fine too. The voltage is slightly lower. It doesn't affect it too much. Basically, it means we're drawing less current. We're biasing the output tube less hot. It's going to give us slightly less power, but it's also going to create less heat, and therefore the longevity of the tubes is improved dramatically. So that also is fine. Right, let's look at the selenium rectifier conversion. The first thing you need to do is to remove the selenium rectifier, desoldering the connection points and taking the whole thing out very carefully. This particular one has these two brass rivets holding it together, and the way you take it out is just to use a drill bit, grind through the heads of those rivets, and as soon as the heads come off, the whole thing comes apart quite nicely. As soon as you take the top off, you see that blue insulator. It's a mica material which insulates the top cover from the contacts inside the actual rectifier. So what you're left with then is the innards of the actual selenium rectifier. What you're seeing are the contacts, and between them, sandwiched between them, are the various elements that make up the actual rectification. And there we have it. Once you've taken it all apart and removed those little rectangle or little squares and the springs that keep it all tightly together, what you're left with is the casing and the four contacts that will make up your rectifier, the two AC inputs and the plus and minus. So what you really have are four connectors, two on the underside, the green ones, which are AC, and then on the upper level you have that orange one, which is the negative, and the red one, which is positive. And now there's nothing between them, so we have to fit the diodes in there. Now this is the circuit that we're trying to achieve here. We need 4 diodes in bridge rectification, bridge rectifier mode, and we need to solder these diodes from the respective pads to the respective connectors and make sure we don't get that mixed up. You have to be very careful when you're soldering this. First of all, to get solder to adhere properly to these pads, it's good to use a bit of flux. Once you've done that, tin the pads, and then you need to bend those diodes very carefully so that they actually go from the AC connector below to one of the connections above, whether it's the positive or the negative. And if you look at the schematic and you figure out how they fit on top of this, they actually cross. So you need to be very careful that there's no short circuit in there, because that would be catastrophic. And the result is there. The pads are all soldered in place. The continuity or the diode checker can tell you whether you've made any mistakes. Be very, very careful here. And a little bit of bending and twisting and ensuring that there are no shorts, and you get it back into the case. And then of course what remains is to put the mica insulator back on. Don't forget that. I did the first time. And then the cap back on, and you're ready to go. And there it is, back in place, soldered in place again. You have to be very, very careful with the soldering on here. You're working with pretty high AC voltages. Make sure that those solder pads and the tags that come out of the selenium rectifier don't touch the chassis. That's guaranteed flashbang there if you're not careful. So you put that all together very carefully, and then after that, obviously, you turn this thing back on with the light dimmers, light limiter, to ensure that there are no shorts. You do get complacent sometimes with these things, so you have to be very, very careful that your complacency doesn't cause some major blast, scare yourself and the neighbors, and probably cause more damage to the radio than anything you've repaired to date. So that's it for now. Everything's together, as you've seen. The next stage now is to finalize some little details, get the radio back into its in the cabinet, do some cleaning on elements of the cabinet and fix up the problems with the speaker, that there were some cracks on the speaker cover.
and then there'll be one more video with showing you all that and testing out the radio once again. Bye for now.